And there it goes. The first burn is complete.
Yep, things look really well on the stage burn result. Apogee, perigee, and everything for the mission looks really good. Engine performance, very well performance by the second stage for this first burn. And things continue to look good as we head into this long coast for this parking orbit.
It's a long coast, and we'll hit that second burn long. This one was roughly 3 minutes and 9 seconds. And Mick, you saw the data from it. All looked pretty good. Then there you go,
Yep,
confirmation.
We're hearing confirmation that we have nominal orbital insertion. As we were looking at the telemetry here, Daryl, that things looked very good. Stage 1 and Stage 2 performed very well on that ascent flight. And we'll continue to follow Stage 2 to get ready for that second burn. And then, of course, what we're really looking forward to, Europa Clipper separation.
It's going to be a beautiful moment. If the pictures are as clear as we've seen so far, we will see it in all of its glorious detail. All right. We will continue monitoring the coast phase of the second stage with Europa Clipper, and we will bring that to you. Of course, any updates that we have, we'll check back in with you in a little bit, but for now, let's send it back to the host desk with Megan and Jenny.
Oh, wow. I mean, if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a SpaceX Falcon Heavy rocket soar off the launch pad with the Europa Clipper spacecraft. I thought... tell you the truth. Yeah, how are you feeling? How was it to see that and feel that, too? I mean, that was honestly one of the loudest and most powerful rocket launches that I've personally felt here on the Cape.
It was very emotional in a good way, right? Just kind of overwhelming with just the awe of it, and that it's finally going up into space, and I feel almost at a loss for words.
Yeah, I know. She was like, I am sobbing. She just kept saying, I am sobbing. I am sobbing. I mean, but everybody can understand that, right? I mean, and this is one of my favorite parts of being part of the broadcast, because I do get to watch it with the co-host, and really, this is so much of your life that you're seeing culminate in a rocket launch.
It is. It's a huge, again, it's almost indescribable, just the amount of time and effort and all the people involved that got us to here, and to witness that moment is just unlike anything I can describe.
And can you believe it? We are still very much at the beginning of this spacecraft's journey. It is headed for Jupiter's icy moon Europa, which scientists believe could be the best chance of finding the mission developed by NASA's Jet Propulsion Laboratory in California and Johns Hopkins University's Applied Physics Laboratory in Maryland. Now, Jenny, why does the team think that Europa is the best chance of finding it?
Yeah, on this planet, every life. And so, that we think that there's this massive ocean of water underneath the ice on Europa is just, how could you resist, So we think that Europa has that water. That's one of the key ingredients for life, along with the chemistry and the energy and the time. It's been kind of simmering away for a long time.
Sure.
It's a great place to go explore.
And how exciting would it be, right, if we could verify that there are the makings of life as we know it on Europa. So let's dig into the science that is going to make this possible.
We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like. Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are shockingly few impact craters. That means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening, and it's performing 49 flybys of Europa.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near infrared, the far infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. And we have another instrument that can tell us the composition of dust particles.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft. And from that, we can get essentially a map of the gravity field.
We can get the shape, understand, what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
And we were proud to host JPL directors here at Kennedy for launch. She's with Tony now, and they both had a spectacular view of launch.